satellites take special relativity into account.
She teaches 152.
We both teach all the topics, but when 152, I think she does optics when I generally do relativity.
Okay.
Okay. Let's actually figure out the acceleration to gravity. Kate wanted to use mg, or at least suggested that. Let's figure out what little g is at this point. So if what we're doing is we're equating this gravitational force acting on the satellite using our classic weight formula, that should be equal to big G mass of Earth, mass of satellite over the orbital radius squared. So to find out what the acceleration due to gravity is, well, the mass of the object is irrelevant, as we have talked about plenty of times, that if I drop two objects, the mass does not affect the acceleration due to gravity. And so little g is just going to be g times the mass of the Earth. Well, let's actually do numbers now. 6.67 times 10 to the negative 11th times 5.98 times 10 to the 24th divided by 2 times 6.38 times 10 to the 6th, and that denominator is squared. Now I know that on the surface of the Earth, the acceleration to gravity is 9.8 meters per second squared, so if I go out twice the distance, I am expecting the acceleration due to the Earth's gravity to be less than that. So if you end up with something bigger than 9.8, there's a mistake somewhere. And I suspect it's somewhere around 2.4, but somebody is going to be kind enough to work this out on a calculator, and it looks like there's a lot of faith being placed in Logan and Giovanni on this. There you go. Okay, good. A voice of confidence.
Yeah, 4.9.
4.9? Did you square the denominator?
Yep.
Yeah, you've been much farther off. So where did my math go off then? Distance. Did you square the 2 in the denominator?
Yeah, that's where we're looking. That's where 2 and 2.
It really should be.
2.45.
Oh, wait. Yeah, no, see where they're on.
Yep. All right. So you said you did see where you went wrong?
That's where that is.
Okay.
Definitely.
Units?
Meters per second squared.
Yep. It's an acceleration. So I'm standing on the Earth's surface. This 2 would go away, and we'd end up with 4 times that, or 9.8. All right. Questions? Yes.
What makes the end units squared? Just because of the denominator squared?
If we worked it out, this has units of Newton meters squared per kilogram squared. That is units of kilograms. Divided by that is meters squared. So meter squared cancels out with meter squared. Kilograms cancel out with one of those, so I'm left with a Newton per kilogram. A Newton, by definition, is a kilogram meter per second squared. Over kilograms, and meters per second squared.
Okay.
Is that what you were going for?
Yes.
Your question? Okay.
analogy is the acceleration, the gravity and acceleration is meters per second squared.
That's the other way. If you get into theoretical physics, eventually you get to a certain point where you just say that big G is just equal to 1. Under the belief that there's a unit system out there somewhere, in which case it would, in which it would be 1, and so let's just go ahead and pretend we're in that unit system. However, we're dealing with SI, so please don't do that. All right, any other questions? Then, I think it's time. I'll need another sheet of paper at this point. So today is the 10th. We'll squeeze it in right down here. 10. So then we have 12 is Wednesday, and then 14 is Friday. Feels like the test this Friday seems a bit sudden. So I'm suggesting the test on the 21st. I've got 1 person in agreement, got 2, got 3, 4,
For what?
5. The test, next test.
What chapters? Is it 4, 5, or
4, 5, and 6.
4, 5, and 6? I mean, this is 6, right?
Yeah. So the 21st test, 1B. That green dot will be there forever.
You can't even see it.
What was that, Alan?
I said I can't even see it.
Yeah, when the paper comes down, I think it'll be more noticeable. The last time I was working at DuPont, I was eating M&Ms. Did I tell you the M&Ms were? It's riveting. So anyway, at one point I dropped one of the M&Ms and it rolls underneath the desk. And I thought, you know, we'll just stay there for now. Months later, it was still there. And so when I was rolling off the project, I said to my colleague, I said, I want you to email me when the M&M finally disappears. It was gone within 2 days. I hadn't even rolled off, and finally someone decided to pick it up.
Did I miss when you retold the accidentally electrocuting middle school story?
I don't know if anyone's asked about my electrocuting a student.
It's not a really normal thing to ask about without context.
Jose. All right, I just want to say Jose was a goof off.
Yes.
You gotta say no. I'm
Yeah.
too invested.
Yeah, no, now, he was primarily suffering from being 12 or 13.
Okay.
That was probably his fatal flaw.
Okay.
But he goofed off a lot, and so we were running, there's motion experiments that you do. We have motion sensors now, which is really nice. If you don't have motion sensors, you could just do timing like you did in the graphing lab, or you have paper tape that's attached to it, and you have a timer which basically makes dots on the paper 60 times a second. And then you can look at the distance between the dots and see that as it goes down, it gets faster. Well, I was at Hampshire College working with these students, and they had spark timers. So instead of using carbon to make dots on a piece of paper, they would shoot a little bit of a spark there and would burn a small little dot on the paper. So first trial goes up, somebody's holding on to this air cart, so you can see them in the lab. They have these air tracks. Most of them are standing upright right now, but lay them down, it shoots air up, you put a little cart on it, and it sort of glides down with minimal friction. So I had somebody holding it, he let go, the cart goes down to the end, making sparks along the tape, and the cart gets to the end, pops off, falls off. Fine. Trying to get Jose at least physically involved, so I have Jose hold on to it. And so he sets up, he puts his hand on it, and goes, ow, that hurt. This is the point where I made my mistake, other than not checking beforehand. I basically bullied him into putting his hand back on this thing again. Said, come on, Jose, just put your hand back on it. Ow, that hurts. Really frustrated with him at this point. And so I say to someone else, I can't remember the second guy's name, but I say, why don't you hold it? And he puts it on and goes, ow, that hurts. And then it hits me, Jose was not goofing off. I touch it, it hurt, just as they've been claimed. What had happened is that when the cart came down to the end, hit the bottom and then bounced off, it knocked off the grounding wire. So now the electricity was looking for some place to go, and whatever human touched it became the ground. That was no one died. There was no lawsuit. I suspect the statute of limitations is over by now. But the lesson to me was, when a student goes, ow, that hurts, I need to take it seriously. Poor Jose. Anyway, there we go. For the world, Jose, if you happen to be watching, sorry.
Might not even remember.
It's quite possible, if not.
Too traumatic to keep in mind.
Yeah. Well, I've suppressed a lot of memories of what I was like when I was that age, so we potentially did the same.
I'm sure he's laughing at it.
Yeah. That's possible. Or it sent him down a bad path and he's in prison right now thinking, one of these days I'm gonna get back at that guy.
Top of the list.
All right, so let's talk about the next topic. We're gonna start with the next topic with, why don't I start and stop this? I know the next topic is somewhat controversial, but you don't have to leave right now.